let's get some practice drawing stereoisomers. Let's say we were asked to draw S2-bromopentane. How could we do that? Well, we could draw pentane, 1, 2, 3, 4, 5. So there's pentane. And on carbon 2, we have a bromine. And what we're going to need to decide, what are our two choices? Well, that bromine can either be a wedged bond or it can be a dashed bond. And only one of them is going to have the S configuration. Now, you could spend an awful lot of time thinking this through in your head and planning it out and trying to get the right answer right off the bat. But that might turn out to be a pretty big waste of time. My advice is to just guess and pick one of them. Let's say we want to have it as a wedge. And then what can we do? We can check to see if we made the right guess. Okay, bromine would be number 1. And between these two carbons, we have a methyl and we have this propyl. This has an extra carbon attached, so this is number 2. This is number 3. And our hydrogen is pointing back. So did we make the right guess? Did we make the right guess? No, this looks like we drew the R configuration. So guess what we have to do? All we have to do is just erase it. I'll just cross it out so I can leave my work here. But I just made the wrong guess, and it's just the bromine as a dash instead. And you could confirm this if you want, but this in fact would be the S configuration. Okay, so that a lot of times we can, it's a lot faster to pick one of the stereoisomers and then confirm it rather than try and guess in your mind what's going to be the appropriate one. So that would be S2-bromopentane. Now what if I asked you to draw the enantiomer of S2-bromopentane? And we already see what the structure of the S enantiomer looks like. And if I wanted to draw the other enantiomer, okay, there's two methods, there's two approaches we can take to this problem. One approach is we could draw the mirror image, because we know the definition of an enantiomer is that they're mirror images of each other. So we can imagine a mirror to the side or to the bottom, and maybe we could draw it like this and draw the bromine here. This would be the mirror image of this if I had a mirror right here, or if I had a mirror right here, you could see it. And so that should be the enantiomer. That's one possible way to do it. Some students have an easier time drawing mirror images than others. Okay, but there's another method we can have, and that is what we can do is we can invert all of our chiral centers. And by invert, I mean swap two groups. So in this case, we're going to keep our carbon chain fixed, but instead of having the bromine be a dash, our bromine is going to be a wedge. That's another way to draw an enantiomer accurately, and so whichever method works for you, they both should result in the right answer. Now, are these the same answer? Are these the same compound? You see that? Well, sure. If I take one and I simply flip it over, they should superimpose. If I flip over one, the bromine that was a wedge becomes a dash, and they will line up very nicely. Now let's check the configuration here. We can do it on this one. Here we have bromine is 1, propyl is 2, and the methyl is 3. It looks like this was the first guess we had up top here, isn't it? This is 1, 2, 3. This is the R configuration. And how about this one? If this is the same molecule as this, it should have the same configuration. Let's check that. This is number 1. This is number 2. This is number 3. And I go 1, 2, 3, but where's my lowest priority group? My lowest priority group is actually a wedge, so I'm going to have to reverse this and go backwards and go 3, 2, 1, 3, 2, 1, 3, 2, 1. Yes, this is in fact also the R configuration. So either one of these got to the right answer. And something that we can observe here is that enantiomers have opposite configurations. They have opposite configurations. So if one enantiomer is the S configuration, the other enantiomer must be the R configuration. That will always be true. And even if you have multiple chiral centers, all of the configurations in the chiral centers of one enantiomer will be the opposite in the other.